In this tutorial, we are looking at all of the various statistical diagrams, including frequency polygons, pie charts, box plots, cumulative frequency curves, histograms, and scatter graphs. Let's begin with frequency polygons. Frequency polygons are graphs that use grouped data. So in this table, we have got information about the numbers of emails sent by 51 teachers on Monday. Again, we're going to practice reading our data from a table. This first row in the table means that 5 teachers sent greater than 0 but less than or equal to 10 emails on Monday. To draw a frequency polygon, the key points are that we use the midpoint of the group as the x coordinate, and we draw crosses and we join each point dot to dot with a straight line. So our first coordinate will be the midpoint of our first group is 5. So let's just complete the midpoints for each of those. And then we plot the frequency. The midpoint is 5 and the frequency is 5. The midpoint of the next group is 15 and the frequency is 17. So that's 15, 16, 17. 25, 14. 35, 9. 45, 6. Then we join each of these points up with straight lines. So use a ruler to join each point with a straight line. And that is what a frequency polygon looks like. Next, we look at a pie chart. Now, a pie chart is a circle where the angles in a circle total 360 degrees. So what we need to work out is what angle is going to represent our total frequency. And we know that all of the angles in the circle need to total 360 degrees. So let's find out how many different birds there are that we need to represent in our pie chart. So 15 plus 10 plus 20 plus 27 is a total of 72 birds. So 72 birds need to represent 360 degrees. So let's work out what angle is represented by every one bird. To do that, we divide both by 72. 360 divided by 72 is 5. So every one bird represents 5 degrees. So that's 15 times 5, that's 75 degrees for our magpies. 10 times 5 is 50 degrees. 20 times 5 is 100 degrees. And 27 times 5 is 135 degrees. We then use a protractor, placing that protractor. Depending on the protractor that you have, you might have a semicircular protractor or a full circle. So we are going to place that cross of the protractor right in the middle, and we are going to put our line from here because our first line has already been drawn. So we are going to go 50 degrees from that point, and we join with a straight line. So that is the thrush. Our next angle is 100 degrees, so we now move our cross and our line round. So this is now the 0 degree point. We measure all the way around to find 100 degrees. Join with a straight line. That's now the startlings. Then we'll just check that our final angle, so we go from the center point, measure all the way round. That is then 135 degrees for the sparrows. Next, box plots. So key points for box plots is that we plot the least value, the greatest value, the lower quartile, the median and the upper quartile. A box plot is a really good visual way of representing lots of data. It allows for easy comparison. So for this is the amount of time girls spent doing homework last week. So just to make a note of how to work out what each box represents. So here we have a total of 10 little boxes that represents 50 minutes. So every one small box represents 5 minutes. So here is 50, which means 60 minutes goes here. Now we've been given the range, which allows us to find the greatest time. So 230 is the range. If we add our least amount of time, which is 60, that meant our greatest amount of time was 290 minutes. 290 minutes is here. The median is 170. The lower quartile 100 and the upper quartile 220. We join the upper quartile, the median and the lower quartile with a box, and then we draw straight lines to join together our least amount and our greatest amount of time. Often questions we get are comparing distributions that are 2 marks. To get the 2 marks for this, we need to compare the average and we compare the spread. So what we're looking at to compare the average is the median. Here's the median for the girls, here's the median for the boys. The scales are the same. We can see straight away that the median for the boys is higher. This means, on average, the boys spent longer doing their homework. Now, longer is a comparative word. We could then say the median for the boys was this, the median for the girls was this, therefore the median for the boys, the average time for the boys was longer than the girls. It's got to be a comparison of boys versus girls. Then we're talking about the spread. Now, to visually see the spread of data, we're looking at the interquartile range. Visually, the interquartile range is how wide your box is. We can see that the girls had a wider box. This meant that the girls' time doing homework was more spread out or more inconsistent than the boys. Or we could say that the boys spent, a closer amount of time or a closer consistency in time doing their homework. Next up is a cumulative frequency curve. Now, cumulative frequency is running total from whatever the original value was. So, reading this row in the table means 5 potatoes were between 100 and 120 grams in weight. The next row means 25 potatoes were between 120 and 140 grams in weight. Let's look at our cumulative frequency. The table starts at 100 grams each time. So the number of potatoes between 100 and 120 was 5. 120 to 140 was 25, which means 100 to 140 is 5 plus 25, which is 30. So we're finding the running total. 100 to 160 is another 30, so that's a total of 60. 100 to 180 is an extra 15, so that's 75. And then 100 to 200 is an extra 5, so that's 80. So what we see here is there is a total of 80 potatoes. key points for cumulative frequency curves is we are drawing our x-coordinate for the final value in the cumulative frequency group, and that's our x-coordinate. We join together with a smooth curve. So now plotting our points. Our x-coordinate is 120, our y-coordinate is 5. X-coordinate 140, y-coordinate 30. X-coordinate 160, y-coordinate 60. X-coordinate 180, y-coordinate 75. Our final point, x-coordinate 200, y-coordinate 80. Join these with a smooth curve. Cumulative frequency curves will always have this general shape. Now we can use our cumulative frequency curve to find the median, to find lower quartile, to find upper quartile, and also to find the interquartile range. Estimate is always because we are using grouped data. So if I wanted to find my median, reminder that's the piece of data halfway through the set. I've got 80 pieces of data, so my median is my 40th potato. My lower quartile is my 20th potato because that's a quarter of the way through the group. And then my upper quartile is the 60th potato. So using my cumulative frequency curve, I can see that the median, we go across at 40, where we hit the line, we come down. So approximately 145 grams is the median. The lower quartile is the weight of the 20th potato, so we come across at 20, hit the line, and we come down. So approximately 132. Everyone's will be different, which is why it's only an estimate, because it will be where you have drawn your curve. But you will have a range of answers that are accepted. And then the 60th potato is about 160 grams. So the interquartile range is 160 minus 132, which is 28. Now we're looking at histograms. Now with histograms, these typically are on higher papers. It can vary where they are in the paper. What you'll notice is that on the y-axis for a histogram is the frequency density, not the frequency. Now a key point with histograms is that the area of the bar is the frequency in that group. So we could say that the frequency, i.e. the area, if it's the area of a bar, that is the length times the width. The length, meaning frequency density, times by the width, which is the width of your group, also known as class width. So we could put this in a little triangle because often we are asked to draw histograms, which means you need to find the frequency density, which is the frequency divided by the class width. Reminder, frequency is frequency density times class width. So in this question we are asked to find the frequency of each group, of which the first one has been done for us. The width of the group is 10, frequency density is 0.4, that's 10 times 0.4, which is 4. So we'll do the same for the next group, that's 10 times 0.8, and then here is 1.2. So let's work out what we're going up in. We're going up here in 0.4, and that is split between 10 boxes, so every one box is 0.04. So that's 0.8 plus 0.04 plus 0.04 plus half a box, which is 0.02. So 0.8 plus 0.04 plus 0.04 plus 0.02 is going to give us 0.9. So here is approximately 0.9. So that's 9 frequency. The next group is only 5 wide, and that is up at 1.6. 5 times 1.6 is 8. Next width of the group is 10 wide, and we're up at 0.8, and then that's a 1.2. We've got it about here. So that's 1, 2, 3, 4, 5 lots of 0.04 added on to 0.8, which gets us to 1. So that is a frequency of 10. Next, the width of the box, the final box, is 15 units wide, and then we're multiplying that by 0.8. So 15 multiplied by 0.8 is 12. So let's look at another histogram, which is slightly more difficult because we have to work backwards. What you'll notice is that we do not have any units on our frequency density axes. So we must have been told a piece of information. 20 houses have a price between £300,000 and £400,000. So we know the area of this box is 20. Now the width of the group is 100. We multiply that by something to get 20. So 20 divided by 100 is 0.2. So here is 0.2. So following on with the axes, we'd expect this to be 0.4, 0.6 and 0.8. Now we have our axes, we can work out the number of houses with a value under £200,000. So that's the area of our first 3 bars we need to find. So our first bar has a width of 100, and we are at 0.2 is 10 boxes, so every 1 box is 0.02. So that's 3 boxes down, so that's 0.06 off of 0.2, which is 0.14. 100 times 0.14 is 14. Our next box is 50 wide, and we're up at 0.6. 0.6 times 50 is 30 houses. And then our next box again is 50 wide, and we're up at 0.8 for that one. 50 times 0.8 is 40. So that's a total of 14 plus 30 plus 40 to get our total number of houses, which is 84. Finally, we're looking at scatter diagrams, and we see this word correlation. If you were to draw a line of best fit, and the line of best fit is going upwards, that is a positive correlation relationship. Negative correlation is going downwards like this in a line of best fit. And no correlation would be something in which you could not draw a line of best fit through your points. This is a scatter diagram to show how 12 girls and their ages take to run 100 meters. What we can see is that our line of best fit would be going in this direction, which is a negative correlation. Typically, part B of a scatter diagram question will use the fact you have drawn a line of best fit. So you must draw a line of best fit. Everyone will be a slightly different line of best fit. So now Christina is 11 years old, and her best time to run 100 meters is 12 seconds. So she's 11 years old, and that's 12 seconds. This would be an outlier. Explain why. And an outlier, as we can see here, it lies a long way, very far away, outside the general trend or pattern of the rest of the points. It's not on or near the line of best fit. If we wanted to find out, for example, the time it might take a 13-year-old girl to run 100 meters, we use our line of best fit, like so.